Hello, in this demonstration we will be looking at Cisco ACI Microsegmentation capabilities in a demonstration using vSphere environments. For our demo, we will imagine that Acme Company is building a new web application for an online shop. Our example will be based on a very simple site using open source Joomla content management system. We will actually be using one of the sample sites that come embedded with the tool. Our application relies on an Apache web server that provides static content and pulls dynamic HTML from a MySQL database. We're splitting off this into two application tiers. We can imagine that our production environment should have somewhat of an scalar approach. So the web front end will be load balanced by an enterprise load balancer, and the combination will be provided access to the external users through a next generation firewall. To make it very simple, we want to have all application tiers in a single subnet. This simplifies IP address management, which makes it easy for a cloud management and orchestration system to replicate this. We will be using an F5 load balancer to front-end our web virtual machines, and we will be using an ASA with a SourceFire module as a next-generation firewall to protect the perimeter. Users will be accessing the web application through IP address 172.16.1.100, which is NATed on the ASA firewall to reach the virtual IP address that runs on the F5 load balancer. The F5 load balancer should balance between the two Apache VMs, but should not have access to the database, even if it is on the same subnet. The web VMs themselves do not need to talk to one another because this is not required by the application, and the web VMs are the only ones that should have access to the database. Or we will be reproducing this environment by creating an application network profile called Joomla app. Our application profile will have two micro EPGs, one for the web production virtual machines, which will be mapped to the VMM vSphere domain, and another micro EPG for a database, also mapped to the vSphere domain. We will use two contracts. One contract will enable connectivity between the web and the DB tier, and another contract will provide access to an external EPG, which is part of an L3 out that provides connectivity to our wide area network. This external EPG also has a service graph. In order to provide the isolation that we need, we will be using micro EPGs selected based on VM attributes. So all VMs will be always in the same port group, which will be based on the base EPG that we will be using for staging the application. That base EPG will only have access to our provisioning systems, but nothing else. Once the VMs have been provisioned, by changing VM attributes, they can be moved into the right EPG, but they will never have to change port groups. We will be using isolated micro EPG feature to block connectivity within the web farm, and the contracts will prevent VMs to connect to the database except for in the protocols on which they are required. The service graph will be used to automate the perimeter next generation firewall and the application load balancer. And this is the demo topology, looking at it in greater detail. We will be doing this demo using the ACI vCenter client that we can already see on the screen. This allows us to see the topology that we just described in our application network profile. So this is the application network profile that we will be using. It's called Joomla app. And as we can see here, we have a basic setup for staging applications. So servers that are not in production that we may be using for later demos and stages for testing or development, etc., are placed on a base EPG Joomla app servers that only have access to our Ansible server and only Ansible traffic. SSH, essentially, ICMP is also allowed from that base EPG. The actual production traffic is on our two-tier application. Again, we see the external connectivity represented by the Acme 1 external EPG, which provides a default route in this case. And then we have web and prod EPGs. I want to show the vCenter view. So in vCenter, we will have all VMs connected to these Joomla app servers port group. So this is the port group from the base EPG that we've decided to use. And here we can see Apache Server 1, Apache Server 2. These are our two web servers in production. And then we have our database MySQL 01. So we can see that there are other VMs connected as well to the same environment, and both tiers are connected to the same port group. We can also connect to those VMs, and we can look at the IP address that they have. Here we're connected to Apache Server 1. If we do an IP address show, we can see it has IP address 172.16.10.12. We can connect to Apache Server 2, and see that they have 1.72.16.10.14 also on the same subnet, and the SQL database, it's also on the same subnet, 162.16.10.200. All of them are on the same subnet, and yet being the same subnet and same port group, they are actually in different microsegments if you want. So .12 and .14 are showing up on our web production EPG, whereas .200 is showing up on our Joomla database EPG or micro EPG. These micro EPGs are configured to select different VM attributes to put the virtual machines onto the EPG. So for instance, here we're selecting by using or by matching a string or a substring on the VM name. Other attributes are also possible. We're also using the intra-EPG isolation so that without any need for configuring any rules, any traffic that needs to be isolated within the EPGs is easily served. So this is ideal for web server farms, DMZs, management VNICs, and so on. So that's it. That's our micro EPG. And with this, we have the possibility of completely blocking connectivity that is not required. Again, if we were to go to Apache Server 1, although it is in the same subnet, same port group, and same micro EPG is Apache Server 2, we can see that it cannot ping to Apache Server 2, which is .14. In fact, if we try to, if this host would be compromised and the attacker tries to scan the network for activity, the subnet for activity, 72.16.10.0, we would see that all hosts are down. If we try to scan specific addresses because we know that they're open, like let's imagine we know the database, because we compromise the host, we can actually look at the configuration and we see that there's connections to a database. Even that scan is going to fail if we actually scan to bypass a firewall. We will see that only the exact ports are open. Like in this case, all ports are filtered, right? The Nmap tried for 1,000 well-known ports. Only MySQL was actually open, which is what the contract is allowing. The contract is only allowing MySQL, and we're only allowing for test purposes. We're also allowing ICMP traffic. So, for instance, we can actually ping that IP address, which is our database, and we can definitely establish connections to that database. And we cannot connect to the other server. The other server can actually ping to that database as well, but it cannot ping to the other server on the same subnet, same micro EPG, because of the isolated feature. The other thing that is interesting to see here is that we can simulate that connection from the external network. So the application is actually working. It's actually working because this contract is enabling access to web traffic and also ICMP, and is inserting at the same time a service graph. So we have a Cisco ASA and a F5 big IP connected to the same graph. This information is also available on the resources tab. So for instance, here we can see a quick inventory of all the L47 services that are available at this point in time in this fabric. We can see here, for instance, that this service graph is providing external connectivity to these web servers and only on these ports and protocols. We can also use this resources tab to give the vSphere administrator an overview of the network. So for instance, here we can see the application Joomla app, and we can see the health score that the network is reporting for all the different EPGs that are involved in this particular application. So back to our application view, we have seen how internal traffic is protected for lateral movement. So we have seen complete lateral movement protection. But what about the perimeter? The perimeter again is automated and protected by the contract model and also the next generation firewall. So we have here, in fact, the GUI to the ASA, and that ASA is already logging connections. So these are connections that are coming from a test desktop that we have right here. And this test desktop is running a script that is just downloading a web page from our production server, which is running on 172.16.2.100. That IP address is in fact the IP address of a virtual server configured on the big IP. So if we go to the big IP, we see that virtual IP address 172.16.2.100, and we see the two members that were dynamically configured by the APIC. So this is the APIC created virtual server, and these endpoints will be dynamically added or removed as well. So our application is working now, and in fact I could connect to it. Application, and the load balancer is actually working as well. We will see that future connections will go to a different server, and so that's all working. If I was to launch an attack from here, so as an external network, one interesting thing, or one other thing that we have here is we combine hardware filtering with the next generation firewall. So the next generation firewall is actually capable to inspect the web traffic that is going towards the load balancer, but at the same time it only sees web traffic, because the hardware filter that we've implied only allows ICMP and web traffic. So if I was to do an nmap to the address, we can see that that nmap is not going to be logged here. I'm doing a port scan against that IP address. Only port 80 is open. The connection to port 80 will be seen by the next generation firewall unlocked, but all the other attempts of attack will be blocked in hardware without consuming resources from the next generation firewall and providing a far better way of blocking that traffic. Now, one important thing when you're blocking traffic is that you don't want to miss anything from a log perspective, but the fabric provides that logging capability. So if we actually come to our syslog server, we can see the ACL log denies as we launch our nmap, and there we go. So we can see these connections coming from our desktop, 192.168.200.100, and how we're doing these port scans. So these logs are not lost yet; they're done in hardware. These logs are also available to the syslog. They're exported to any syslog server. They're also available to the fabric administrator, which can see them on a per node device or per port device on the events tab. What we have used to perform this demo: an ACI fabric running 131G, vSphere 6.0, but this demo works just fine, just as well with vSphere 5.1, 5.5, or Microsoft Hyper-V. A next generation firewall, we used ASA in our case. It could be virtual or physical. An ADC, we can use from any of the partner load balancers, virtual or physical. And there are no licenses required per server. The ACI fabric does not require any per server licenses. Also, there are no requirements for any compute nodes to do routing and switching. And finally, a single management point for all overlay and underlay configurations and provisioning is required, the APIC. Thank you for watching.